And thank you all for being here today. That I know you're very busy in your shops and in your personal lives, so I do appreciate everyone taking the time to be on this today. And some of you have been on before, got to look at all the names that we've had, registered and everything. Currently we have 250 people on today. So again, thank you very much. And this is Multimeter 102. Some of you have been on here before for our fundamentals of multimeter, and we're just going to go into it a little bit more. And one of the things we're really excited about is the fact that we do have the online test. It is 27 questions. It requires you to get 22 of those correct, but if you do, it will generate a certificate for you with your name on it. So we want to support y'all any way we can, and not only provide training, but also some feedback of how well you did. One of the biggest things is we see a lot of people. I know how to use a multimeter. Why am I spending my time doing this? I don't know anyone that can't use a refresher. I spend time on YouTube and looking at all kinds of different videos and things, figuring the best ways to I can use a meter and to train other people how to use it. This is not going to make you an expert today, but at least make you more and more familiar with all the different functions. And again, some advanced functions we've never talked about before. So when we talk about a multimeter, it is a meter that does multiple different things. And it generally, as a rule, people use it for one or two functions, not all of them that there are. A lot of times, I don't even know what that symbol means. Well, hopefully we'll educate you on some of that and get you more comfortable with it. But when we talk about a multimeter, it's a voltmeter, amp meter, ohm meter, does diode check, continuity. And some of the new things we're going to talk about today are frequency, pulse width modulation, min-max functions, and relative function. These are all work with those other actual functions of the meter, but give you a way to get even more out of the meter. So we want to spend some time with you and go through all those different functions. But we're going to start off today. Austin's going to go over the pre-checks of a meter. So I'm going to turn it over to Austin and let him go through section 1.
Thanks, Larry. I'm going to go over all of the pre-checks before you start using your multimeter, and these specific slides we're going to show you our multimeter that we have for sale. So the first part that you should always do is check the battery and ensure that your battery is properly charged. That can usually be displayed on some type of symbol on the screen itself, and ours particularly, it's in the lower left. Make sure the battery is functioning properly to make sure you're getting the optimal performance out of your multimeter. If you are to change the batteries, on our specific one, there's 2 screws in the back that you remove, and then you replace it with a D battery. Make sure you spend good quality money on a battery. Don't go to the dollar store and just get a cheap $1 D battery. If you do that, those have the tendency to corrode, and if you don't use your multimeter that often, you're going to throw it in your toolbox and take it out in a couple months, and when you take it out, it's going to be green and corroded and might not function how it used to. With the next part for pre-check, we're going to be testing the meter itself along with the leads. So in order to check the leads, make sure that you turn your meter to ohms. With ohms, you'll be able to see if there's any type of resistance through the meter or through the leads itself. Having the positive lead plugged into the volt port and the ground lead plugged into the ground port, you can touch the 2 leads together. In that slide, you can see that there is 0.04 ohms on the screen, meaning that the leads themselves are defective. There is some type of resistance in there. If you touch them together and do not have any ohm reading on the screen, you can be rest assured that those leads are functioning properly and have no type of resistance. Now, for testing the meter itself, you can actually just take a paper clip and essentially do the same thing, plug it into the port for the volts, and then the ground itself. If you get any type of ohms, for example, on this one, you can see it's 0.8 ohms, we can be assured that the multimeter itself is defective and needs to be recalibrated. If you do not have any type of resistance, which is what you want, you do not want any type of ohms reading when you do the paperclip test for checking the meter, then you can be assured that your meter is functioning properly. The next part we're going to go over is testing the individual leads themselves. So with everything unplugged, plug the red positive lead into the volt port, and then take the probe and put it into the ground. If you have any type of reading, again, you can figure out that that specific lead is in fact faulty. If there's no lead, if there's no ohms or any type of readings on your screen, you can see that the the probe itself is functioning. And then the same goes for the ground itself, but just flip the lead. So take the ground and plug it into the ground port, and take the probe and plug it into the volt. If you have a reading of ohms, then that specific lead is faulty. If there's nothing, then the lead is good. For pre-check, there's another series for putting it in auto versus manual for checking your voltage. 90 to 95% of the time, you're probably going to leave it in auto. The only time that you really put it into manual is when you're doing something that probably requires less than 2 volts. The manual just seems to be faster at picking up anything lower than 2 volts. But most of the time, you're going to leave it in the auto function. To get there, you can usually see auto on the screen. If there's nothing on the screen, then you can, as you can see in the next slide here, there's no icon. That means that it's in manual mode. The next part is going to be AC versus DC voltage. It's very important that you understand the limits and/or capability of your meter. Our specific meter has a range for AC voltage of 0 all the way up to 1,000. You can figure this out by going and clicking the mode button. That's going to change you between AC and DC. The next part that you can see is switching to DC by clicking the mode button. And again, the range for our specific units is 0 all the way up to 1,000. Be sure to check the capability of your meter, though. From here, I'm going to hand it back over to Larry to talk about testing for current.
All righty. Thank you very much, Austin. One of the biggest things that all the things that Austin talked about is you got to make sure you're familiar with your meter and the meter's ready to use. If you don't have your own meter, a good example is a lot of guys, gals, technicians on today's webinar have taken part in different Super Tech events. If you are going to, get involved in one of those, one of the biggest things I tell you to help you is bring your own meter. Bring what you're comfortable with. If you're always borrowing, your friend's meter, you need to make sure you understand that meter. If you try to use a meter that's, doesn't have the right, capacity, you're not going to get, the right test results. And if your meter is not in proper working order, it's not going to work right. So you got to make sure you're familiar with that meter, what its limitations are, and how it functions. But going from there, we're going to talk about a voltmeter. It's probably the most common used thing on a multimeter. And generally, people do a pretty good job of using a voltmeter, but there's a lot of things that a voltmeter will do people don't ever use. And one of the things we're going to talk about right now is just basic, what does a voltmeter do? Simple answer, it tells us the difference between 2 different points. That if you look at the slide, you got a battery that's sitting there at 12.5 volts, which is almost 100% state of charge. That, a fully charged lead-acid battery should be approximately 12.65 volts to be completely charged. There's a lot of misconceptions on that. And remember what I told you on that. That could help you later. But we put our voltmeter across it. We put red on positive, black on negative. What does our red lead read? Answer is 12.5. What does our black lead read? You're at 0 at the battery, so it's going to read 0. What is the difference? 12.5. That's the only thing that voltmeter does, is tell us the difference between 2 different points. Now, I can take that same battery, but I'm going to grab a starter and a couple of cables, just like you'd have on a big truck. And right now, we have no current flow. That truck is just sitting there. So I can move my leads anywhere I want to on this truck. Now I've got my red lead on the starter positive. I've got my black lead on starter negative. My red lead is still going to see 12.5. My black lead is still going to read 0. Difference is still 12.5. So I can move those leads anywhere I want to. If you look at the next slide here, I've got one on battery positive and I got the ground on starter negative. Still does not matter. I still see 12.5 on the positive side and I still see 0 on the ground. If I were to hook those leads up backwards, what would it display? Negative 12.5. It just says, hey, silly, you hooked me up backwards, no harm, no foul, but just let you know you are hooked up backwards. That's the nice thing about using a digital piece of equipment is you're not going to hurt it. It's going to give you negative. If you were using an old analog or needle type meter, if you hooked it up backwards, it's going to try to move the needle the opposite direction. And at the very least, you're going to sacrifice the calibration of that meter by doing that. So you do have to be careful. You are using the old analog, digital, no harm, no foul. Just let you know you are hooked up backwards. Now, everybody always wants to use a voltmeter with red on positive, black on negative. Can I use a meter positive to positive? Answer is yes. And again, we're showing right now a common circuit of a battery to starter, but it doesn't matter what circuit we're talking about. This could be a blower motor, this could be a headlight, whatever. But if I have my red on starting point of the circuit, which is the battery here, I put my black on starter of, or positive of the starter, I'm still going to read 12.5. What is the difference? 12.5 on both sides, difference is 0, so my meter displays 0. Does that mean I have 0 volts there? No. Put a screwdriver between that post and the case of the starter, you'll find out real fast you do that power. And Snap-on will not warranty those screwdrivers if you do that. Not that I've ever done such a thing. But again, showing you I can move this meter anywhere I want to in these circuits, and all I'm looking for is a difference in potential. Now, if I were to hook it up just like this, and my meter showed 12.5, what would that immediately tell you? I'm going to think about it for a minute. I should be seeing 12.5 on battery. I should be seeing 12.5 on starter, but suddenly my meter displays 12.5. What's wrong with this circuit? Should immediately tell you that, boom, I've got a break in that wire somewhere. Now, odds are probably very strong that it's never going to happen on a big starter cable. But again, this can be any circuit on that car, truck, golf cart, you name it. Wiring's wiring. But it should immediately tell you got a break in that wire. And again, going back to tech events, a lot of times I'll see somebody trying to troubleshoot a board, and they will skip over, finding the problem because 12.5 is a good number. They immediately assume that's a good reading. Stop and think, what should this wire be? What should this reading be? Now, if I can use a meter positive to positive, can I use a meter negative negative? Answer is yes. If I have my negative on negative on battery ground, and I've got my positive over on starter ground, I'm going to see 0 at the battery. I'm going to see 0 at the starter. Difference is 0. Nothing from nothing leaves nothing. So does not mean the wire is good. On any of these things we're talking about right now, all we're looking for is readings that we know the wires are connected. In order to have voltage drop, what do we have to have? We have to have current flow. And suddenly, we do. Now, instead of that truck just sitting there, someone engages the starter. And for simplicity, we're going to show 2 different meters so we can kind of take a snapshot at one time. So I've got 1 meter across the battery. I got another one across the starter, but the one across the battery we're going to talk about first is the red is connected to battery positive, the black's connected to battery negative. The red lead sees 8.5 volts. The black lead reads 0, so that tells me I have 8.5 volts across the battery. I take my second set of leads and have them across the starter. My red lead sees 7 volts. My black lead reads negative 0.3. The difference there is 6.7. So if I look at that entire circuit, I go from 8.5 under load all the way down to 6.7. So how much voltage drop do I have in that entire circuit? When we say entire circuit, how much is in the positive cable and the ground cable? Do a little math there, but it comes back and says we have a 1.8 volt drop. Where is it? Don't know. But again, if you keep playing with the meter, there's different things you can do. That I'm going to check just the positive. So I'm going to go from battery positive to starter positive. Difference is 1.5. So I know I have a 1.5 volt drop in just that positive cable. Now, remember we all took algebra, we swore we'd never use that? But what was the basis of algebra? If you knew 2, you could always find the third one, correct? Going back to the previous slide, how much voltage drop did we have total? We had a 1.8 volt drop on the positive and negative together. We just checked the positive by itself and we had a 1.5. So how much is left over? 0.3. That's what we came up with going from battery negative to starter negative. Now, a lot of you may be familiar with TMC RP129, which is a voltage drop spec for cranking cables. The spec for that is you're allowed half a volt at 500 amps. So we just tested this and we had a 1.8 volt drop. Is this, circuit good or bad? Some of you are going to say, oh, it's good. No, wait a minute, it's bad. It's more than half a volt. Well, actually, I can't tell you the answer to that because what don't we know? We have no idea how much current that starter is pulling. And the other thing, too, if you look at it, a starter, is all over the map because one of your biggest factors on engine crankability is oil viscosity. So if that engine's very cold and it's got very thick oil, it's going to pull a lot more current than a nice 80-degree day or a nice warm engine, synthetic oils. All those things make a very important part. So you can't ever use the starter to do this test, but it gives an example of it. But again, if you go back to TMC spec, you're allowed half a volt at 500 amps. With 1.8 volt, we would, obviously exceed that rule. But if we're allowed half a volt at 500, how much would we be allowed at 1,000 amps? Twice the current, you'd be allowed twice the voltage drop, so you'd be allowed 1 volt. Well, if you pulled 1,500 amps, 3 times the current, 3 times the voltage drop. So if this starter was pulling 2,000 amps when it was a very cold day, very hard to crank, you'd be allowed 2 volts, so technically it'd be well within spec under that. So you have to know that in order to have voltage drop and do a voltage drop test, you have to have a load. On top of that, you have to know what the load is. If you're trying to do a voltage drop on, say, a blower motor circuit, something that may handle 30 amps, and if you use a test light that only pulls 1/4 of an amp, is that a fair test? No, because you're not ever going to load it down anywhere near what that circuit would be loaded under application. Same thing if you're testing the 7-way on the back of a truck going to the trailer. There's all kinds of companies that make little LED indicators. The only thing that those are going to tell you is the fuse is not blown or the breaker's not tripped, because that load is so small, they will glow or light up, whatever, with so much voltage drop, it's not a fair test. But the rules for voltage drop is, again, in order to have voltage drop, you have to have current flow. You have to know what that load is. And that's the only thing a voltmeter does. Next thing we're going to talk about is an amp meter. That you have to have, voltage to push current. Amp meter is going to read how much current that is. If we use the old water analogy, that there is a pump or, water tower up on a hill or whatever, creating pressure, trying to move that water through all the pipes and deliver water to your house. Your water meter tells you how much water you used, how many gallons, just flowed through or drops or whatever, but that is the reading of flow. When we talk about amp meter, there's actually 2 different types of meters. The first one we're going to talk about is a shunt type or an inline amp meter. This is what your meter has in it. And if you all have brought your meter to the webinar today, take a look at your meter. The one we're talking about right now is the one that we sell, and we're just using that as an example. Meters are all different, but they usually do all the same functions. But for this one, we have a 10 amp fuse in it. Before you try to use this meter, you got to make sure that that inside fuse is good. Just like we did our lead test, you're going to put your meter on ohms, and you're going to use your red lead, leave it plugged in the voltmeter port, but take it over to the 10 amp port for the using the inline amp fuse. You should read basically 0 or very low resistance. Generally, it's either going to be very low resistance or it's going to be an OL. If it's OL, tells you, hey, the internal fuse is blown. This is what those fuses look like. The one on the left is a 400 milliamp fuse, and then the one on the right is a 10 amp fuse for the top one we just checked. These are special fuses. If you do something foolish and you blow this thing, you cannot replace it with a Wrigley's wrapper. You cannot replace it with a 22 shell. You cannot replace it with an old glass fuse out of your old Ford pickup. These are special, and they're designed to be a fast-acting, slow-blow fuse to protect your meter. So if you do blow one, spend the money. When I say spend the money, these things are usually about $15. So be careful when you do use them and make sure you replace them with the right one. Depending upon brand of meters, if you do have a milliamp port, Some of them you can check the same way we just showed you by putting the red lead in that 10 amp or the 400 milliamp port. Some of them you can do the checks on this particular meter the way the circuitry is done. It will not allow you to check it. It's going to show OL regardless. So you may have to open up your meter and check it. But the 10 amp, pretty much every meter I've ever checked, you can check that way. The biggest question people say, why would I ever use this? What do I need it for? Right now, in today's current conditions, there's a lot of trucks that are being parked because of a lack of freight. And as those trucks sit, for some reason, they don't start, a couple weeks later. That all trucks have parasitic draws on them. And that's, the memories of everything, that you have an engine ECU, you have an automatic transmission ECU, ABS, collision mitigation, your stereo has, memories to it, clock's constantly running. So all these things are creating a draw on the truck. But you say, hey, I got, 5 of them, there's nothing wrong with. The 6th one, it is deader than a hammer. What's wrong? There's one of 2 things. You either have a defective battery that is slowly discharging the entire battery bank, or we have some sort of device staying on. It may be a bad switch in a bunk light that, is staying on even though the bunk's not raised up. Could be a bad relay, but something is staying on, pulling more current than it should. Because if it was just the Qualcomm unit or the engine ECU or whatever, then every truck would be equally dead. But he's got that one that is dead all the time. A couple things you can do is, one, like we're going to show you, actually do a check on the parasitic draw, or the other thing is pull the battery cable. If it stays, the batteries stay charged when you hook it back up over the weekend and it cranks up, so it wasn't a bad battery draining, it was obviously some sort of parasitic. Now we still got to go back through and find it. But in order to use this meter, we got to put it inline in the circuit. That we generally recommend using the ground side just because it's safer. The thing you have to be very careful about is you may have 5 or 6 grounds on this truck. Main starter cables, you may have a chassis ground, cab ground, whatever. This is a very simple drawing right here, but imagine all those different ground cables put together, bolt them together so you're checking every single path back to ground. If you had a very large parasitic draw, you don't want to put your meter in line because it's going to blow that fuse. So handy tool we came up with, not like we can take a lot of credit for it, but just an inline fuse holder and put clips on both ends. Put a 10 amp fuse in it, put it in line first. If it blows that 10 amp fuse, obviously don't put your meter in line. But we put the inline fuse holder in first. It did not blow, so we know we're below the 10 amp. So now we can put our multimeter in line. And if you look at the way it's connected right now, it's going parallel to that fuse holder. The reason you want to do it this way is whenever you disconnect a battery cable, all those devices are trying to stay powered up. It's going to, you pull the cable off, you'll see it, arc as it's trying to keep current flowing, it's trying to jump that air gap. Same thing whenever you reconnect your battery cable, you're going to get that big inrush of all those electronics you're trying to recharge. This is especially true on an inverter. Inverters have very large capacitors in them, and we even put in our instruction manual that you will experience a large spark when you first connect it. Doesn't mean there's anything wrong with the inverter. It's doing exactly what it's supposed to, it's trying to recharge those capacitors. Now, if you hook it up backwards, you're going to get an even bigger spark, and you're going to have to replace the inverter because you just hooked it up backwards and damaged it. But again, we're trying to avoid that big inrush of connecting it. So we have the inline fuse holder, and we have our meter in line. Thought question for you. If I had a 2.5 amp load on right now, with the way that meter is connected, what would my meter display? Got 2.5 amp load. And if you look at it, actually the meter is giving you the answer. Basically, it's going to be pulling half of it through the meter. And the reason why is you have 2 different paths of that circuit. Half is going to go through the fuse holder, half's going to go through the meter. Now, it may not be exactly half, but, somewhere around half. Now, as soon as I pull that fuse holder out, now it all has to go through my meter, and we're getting a very accurate reading saying, hey, we have 2.53 amps of load staying on right now. What is it? Don't know. We got to go back through now and try to isolate it down. But the reason I say it like that is if you did miss a ground cable when you're doing this test, would it be a fair test? No, because you're going to have current flowing through that other ground cable you didn't connect here, so you got to make sure you get them all. But yes, we found out we do have a 2.5 amp load. Are we done? No. What's the easiest thing to do? You start pulling fuses. You pull out the HVAC fuse. Nope, still there. Put it back. Pull out the headlight fuse. Still there. Put it back. You just have to isolate it down to what circuit it is. And then even then you're not done because now you got to find out what is all is on that circuit. You know, if it's a courtesy lamp, is it an overhead lamp? Is it a bunk lamp? Is it under dash lamp? All you know, hey, I've isolated it down to the right circuit. I'm not done. The other thing, too, is you got to keep in mind that whenever you do this type of test, you just disconnected power and reconnected it. So lots of devices are going to go through a startup mode and pull more current than normal. And the other thing, too, such as tracking systems or whatever, they're going to be up in full operation mode, depending upon how they're set up. It may be 5 minutes, 10 minutes, an hour, you know. So you need to make sure you understand those so you're getting an accurate reading of what that load is, you know, constantly, not just initial load when they booted back up. Next meter we're going to talk about is a clip-on amp meter, an inductive amp meter. There's pros and cons to both meters. The first one we talked about, you're limited to 10 amps. Some multimeters may have a 20 amp function, but still very much current limited. And they require you to break the circuit, but again, accurate. The other type does not require you to break the circuit, and you can simply go over the cable, and it's going to read the magnetic flux. Anytime we talk about this magnetic flux, it's what we refer to as the right-hand rule of electricity. Imagine that's a power cable, and you see the arrows for direction current's flowing. If you put your right hand on that cable, put your thumb direction current's flowing, look at the way your fingers wrap around it. That's the way it's going to generate that magnetic field. Now, that's what this meter is designed to do, is read that field or magnetic flux, see how strong it is, and it converts it into a number. Your meter is going to decipher that and display, hey, we saw X amount of magnetic field, we must have 37.2 amps flowing through or whatever. Keep in mind there's limitations with this type meter. Depending upon the size of the jaw, that if you looked at this one with this, that's probably about the size of a 50-cent piece. If you had a 22 gauge wire going through it, is it going to be super accurate? No, because there's a lot of space around it. There's other ones that are rated much higher that have a much bigger jaw. Even if you had a 1/0 cable through, you're going to lose some accuracy because again the size of the jaws. And like anything else, you get what you pay for. How well are they shielded? But if you notice inside these jaws, there'll always be a little sticker or an arrow cast into them that tells you the direction. If you were to check an alternator and you put it on the wrong direction, it's going to give you a negative, say, negative 150 amps. Does that mean that alternator sucked at 150 amps? No, it just says, again, silly, you put me on backwards, flip me around. No harm, no foul, it's not going to hurt anything. But when you do use these, there are certain things you got to remember. Jaws have to close all the way. If they don't, you're going to lose accuracy. You have to zero them out. These things are susceptible to all kinds of electric, fields from other devices, such as fluorescent lights can sometimes mess with them. Static electricity, solar flares can, mess with these a little bit. So you want to make sure you zero them every single time. The nice thing about modern ones, they have a button to zero them. The old ones, I'm not sure if anyone remembers them, used to have what they call a thumb wheel. You have to push it in and turn it. The meter says, 5 amps. You turn it backwards a little bit, it jumps all the way to negative 14. You go the other direction, it jumps back up to positive 12. Very difficult to ever get completely zeroed out. So the zero button makes it much easier. And again, the arrow for direction. A couple other rules of thumbs I always try to mention to people is, if you have a positive cable going from the alternator to the batteries, what do you probably have running right next to it? Ground cable. If you were to put that around both cables, what's the meter going to read? Pretty close to zero, because those two fluxes are going to cancel each other out. Same thing if you're trying to check one wire in a big harness. Make sure you pull it out of the wire loom or whatever. Pull that wire as far as you can away from the other circuits, so you're only reading that one. So Again, very accurate, much easier to use. You don't have to break the circuit, but they are limited on some of these things. And again, definitely, you get what you pay for. This is not a piece of equipment, multimeter or clip-on, you should ever be buying from the discount tool store. You got to buy something that's good for what you're trying to use it for. In summary, what does an amp meter do? It only reads current. In order to have current flow, you have to have voltage, something pushing it. Next thing we're going to talk about is Ohm meter. And I'm going to turn it over to Austin here in a second, but I've always got a good story I always like to share when we talk about Ohm meters. Is, again, people say, I know how to use an Ohm meter. Why do I need to use this class? So I got a little question or test for y'all. Is you have a service bulletin. Service bulletin says you're going to check the XYZ sensor. I have no idea what an XYZ sensor is, but there is one. But the spec says it should be at least 6K. So you grab your meter, you grab the sensor, you hook it up, and you test it, and this is the reading you get. Is that sensor good or bad? Let you think about it for a minute. If you are in a classroom, you can argue a little bit. But spec says it should be at least 6K. This is what your meter displays. Is it good or bad? That's all there is for the testing of this sensor. And this was taken from an actual common service manual. So it's not something I just made up. But it found to be a pretty good eye-opener for people of, do they understand what this meter tells them? But again, the spec says you're allowed 6K. 6K is 6,000 ohms. Your meter displays 5.46. But if you notice, there's that big M next to the omega symbol or ohm symbol. What that actually is telling you, that is 5,460,000 ohms. Obviously, that is much bigger than 6K, so it is a good reading. All they're looking for on that is a infinite reading. They consider anything over 6,000 to be good. So hopefully it's a good eye-opener to say, ooh, did I get that right? Did I understand what that meter was just telling me? And I'm going to turn it back over to Austin now and let him go through some more covering the Ohm meter.
Thanks, Larry. So the next part is just going to review reading an Ohm meter and making sure that we're all understanding the various measurements that are in place. So as Larry went over with the position 1, I'm going to move on to position 2. So position 2 gives you 99.0K ohms. Now, remember, M stands for millions, K stands for thousands. M is 10 to the power of 6, K is 10 to the power of 3. So for 99.0K ohms, what is that reading? If you guessed 99,000 ohms, you were correct. Moving on to position 3, 9.58 M ohms. Again, I'll give you guys a minute to figure out what you think that reading will be based off of what I just explained and what Larry explained earlier. If you guessed 9,580,000 ohms, again, you were correct. Remember, take a look at the M behind it or the K. Position number 4, 0.990 M ohms. Again, I'll give you a minute to figure out what that would be. If your guess was 990,000 ohms, again, you are correct. Remember, M is 10 to the power of 6. Let's try another one. Position number 5, 9.76K ohms. Remember, K stands for thousands. The answer for that one would be 9,760 ohms. Let's try position number 6, 21.71K ohms. The answer for that one would be 21,710. Position number 7, 0.546K ohms. The answer for that one would be 546 ohms. Remember, because it's behind the decimal point, therefore it's not a full 1,000. Position 8, 14.85K ohms. By now, I'm thinking everyone's probably going to get the hand of this one. Let's see what the answer is. If you guess 14,850 ohms, you are correct. We're going to give this a try a few more times. Position number 9, 0.983K ohms. So similar to the couple previous ones, it is going to be 983 ohms. And last one, 3.239K ohms. And the answer for that one is 3,293 ohms. Historically speaking, typically you can look at the comma, and the comma would be in place of where the period would be. So for example, this is 3.239 thousand. It would be 3,239 ohms. So I'm going to hand this one back over to Larry. He's going to talk about using an ohm meter for testing a relay.
All righty. One of the biggest questions, or things about ohm meter is, where I'm actually going to apply this, and why is it important to know? And it used to be there's a lot of components that weren't nearly as important, and trying to get back to my slide here. But how do we apply what we've learned on an ohm meter? Okay, I understand what the K means, the M means, and everything. And just as a refresher, that if you have no symbol, just the Greek letter omega or ohm symbol, that's a straight reading. If you have K, it means 10 to the third power. M means 10 to the sixth power. So, and we're going to show you a cheat sheet that you can go to our website, and it should be in the resources as well. But gives you the ability to see what those are as a good refresher. But, how do I apply some of this? And one of the most common things that people just have a tendency to just swap is a good old-fashioned 5-pin relay. I mean, how many relays like this are there in the truck anymore? 15, 20, 25, depending upon how it's spec'd, but there's a bunch of them. So what would be the first thing we would check? We would check the coil. If I go from the two sides of the coil, it comes back and it gives me a reading of 102 ohms. Is that good or bad? And it says, well, see on your slide it says good. Well, yeah, you're right. How did I know that? I had to go to the manufacturer's spec sheet for that relay and find out what the spec is. Spec on it is between 100 and 105 ohms for that particular one. So I know it's good. Now, the biggest thing people say, why do I care? It clicked and it worked. Well, yes. And the other thing, too, is where's most people's time they ever, first experienced a relay? And I'll say it's back when I bought my first set of fog lights for my old pickup truck. In the box was 2 fog lights, some wire, a relay, and a toggle switch. Guess what most people do with the relay? Don't need that. I'm just going to use my toggle switch. Well, the whole idea of a relay is to give you the ability to control a high current device with a low current switching circuit. So you can have that switch on the inside, and it allows those relay to be turned off and on remotely, so you don't have to run all that current through that toggle switch. But again, people don't realize why it's important. And now, instead of just a toggle switch, what controls most relays in a truck? Well, you got some sort of a SAM module or a body controller or a HVAC module. Something controls that relay. And if you do the check on it right now, if you use Ohm's law, if you take the voltage, which we're going to use 12.5, that's our system voltage, we divide it by the 102 ohms, it says that relay should pull 0.12 amps for that coil to energize. No big deal. That's a good relay. Now, we're going to check another one. Go across this one and we get an OL reading. What does that mean? I don't know if anyone's ever taken a relay apart, but you got a little, steel core, and there's hundreds of loops of, almost hair-size copper wire going around. Whenever you energize that coil, you create a magnetic field and makes a little arm move. But if we have an open, or an OL in this example, that says somewhere one of those loops is broken. Do we care where? No. But it is an open, no current can flow, so it cannot operate. The next one we're going to check go across the two relay or coil terminals again. This time we only get a resistance of 54.2 ohms. Clicks. Has continuity. Seems to work. Why do I need to worry about it? Well, if you again use that same Ohm's law we did before, the first time with a coil that was good, it pulled 0.12 amps. Now with this one, is if resistance goes down, current must go up. So running the calculations, 12.5 volts divided by 54.2, now that same relay, or at least looks like the same relay, now pulls 0.23 amps. Well, if this was an HVAC relay that was controlled by a module, what's going to happen to that module? It could either A, damage the module, so now you had a $3 relay that just took out a $300 module, or the module may shut down or shut off power to control that relay because it saw, hey, it's pulling more current than it should, so it shuts down to protect itself. Well, if you don't understand why it's doing it, you can spend a lot of time trying to troubleshoot this system when it's simply a bad relay. And it may not just be a bad relay, it may be some generic one. Hey, we got a great deal on these, and we bought 400 of them, we got them for 29 cents. Well, you get what you pay for. So you need to make sure you check that. And someone had a question here about answering or checking to see if you had a diode. Yes, that is a very good question. Thank you for mentioning that. A lot of diodes will have a diode suppression across them to eliminate arcing. Pretty much any relay is going to tell you if it is a diode suppressed relay. Check it for the resistance, but also use your diode function, which we're going to talk about in a minute, to make sure that diode is good. So, again, thank you for bringing that up in the questions. And we will cover that in a minute on diode checking in the next section with Austin. But again, going to this relay, it's not simply a yes, it either works or it don't. There is more to it. And, everyone be honest, how do you typically check a relay? My favorite thing is the guy reaches over and hits the horn. Horn works. I'm going to grab the horn relay and swap with the one I'm not sure if it works or not. Again, not a fair test, that you can have other things wrong with it. And you could either, again, damage a more important component, or you're going to spend a lot of time trying to troubleshoot it. Now, the biggest thing when we talk about all these things, too, is Ohm meter is very handy. But if you don't know what the specs are, is it a fair test? No. A lot of times a guy, call me, hey, I use that Ohm meter like you're telling me the other day. I went out and was checking the blower motor on my old pickup. Cool. What was it? He goes, 62 ohms. Awesome. What's it supposed to be? I don't know. Well, what good does it do to check it? If you don't know what the value is, you don't know if it's a fair test to know if it's good or bad. Now, just like we use the formula here, you can kind of run it through that formula and says, blower motor's typically going to pull, maybe 15 amps or whatever on high. Well, if I go through this, I can do the checks and says, according to the calculations based on the resistance check, this blower motor is going to pull 172 amps. Probably not right. Or you may go the other direction and says this blower motor is only going to pull, half an amp. Again, it kind of gives you some idea you're out of the realm, but nothing replaces actually looking up the specs of what it's supposed to be. So we talked about just checking the coil. The other thing you can do is to check the contacts. Now, all we're doing right now is making sure they are either open or closed. And this is a 5-pin relay, so we have a set of normally closed contacts and a set of normally open. First, we're going to check the normally closed, go across it, have a very low resistance, say, hey, they are closed. You can go over to the normally open, and you should get a OL reading, say those contacts are truly open. The other thing you can do is you can actually energize this relay and do your test backwards. Your normally open would now be closed, and your normally closed would now be open. Again, all this is telling us is those contacts are either opening or closing. Doesn't tell you anything about the integrity of those contacts. That most relays are in a live circuit and they make and break, while power is flowing, and they are going to get arcs, burn, damage those contacts. The best way you can really check one of these relays is put it back in service. Say we're using the blower motor as an example again, is put it back in service, put your blower motor on high. And what was the first function we talked about today? Voltmeter. You can take your voltmeter and go across those contacts and see how much voltage drop you have. So many ways you can apply these things and actually test it under load. So what's an ohm meter do? Only tells us the resistance. In order for it to be, a good tool, though, you have to understand what that meter is telling you. What is a K, what is an M, and equate it back to, a good or bad reading, and you have to know what those specs are. I'm going to turn it over to Austin now. He's going to talk about the diode check that we just mentioned.
Thanks, Larry. So diodes, for people who don't know, kind of work like a electrical one-way check valve. They allow electricity to flow through one specific path, but not backfeed. Now, in order to test for a diode, make sure that your multimeter is actually set to that through the actual mode function until you see the diode symbol at the top, and then turn the dial at the bottom to the diode symbol that we previously showed in the last slide. Remember that you must provide enough voltage to forward a bias diode. With this, we're going to go through the actual testing for diodes. This specific one was off of an older Greyhound bus. I think it was from the 1950s, if I'm not mistaken. The first thing that you should do is ensure that the current is flowing in the right direction. In this specific example, you can see that the current cannot flow in that direction, so you're going to have an OL, or out of limits. In this thing, you can see that we switched the leads, so the positive is now on the left and the negative is now on the right. The current flow in this direction is 0.3 to 0.6 voltage drop. This is with the diode closed. With the diode open, we're going to get an OL, or out of limits. Now, a shorted diode basically means that the electricity can pass through both directions and therefore is shorted. The next part of diode testing is a continuity test. This is where you set the multimeter to essentially make a beep when electricity has met itself again. This comes particularly handy when you're trying to test if multiple wires have been molded into one specific mold and might be touching each other when they're not supposed to be. Now, while continuity test is a really good and easy, fast test, you can get burned on it because if there is corrosion in it, or if all of the strands of cable happen to be separated and all but one remains, you're going to get continuity through that. So it might not always be an accurate test. From there, I'm going to pass it back over to Larry, who's going to talk about a few more functions.
All righty. Thank you, Austin. One thing I do want to stress on the continuity check, if we go back to that last slide, is continuity check just says that you do have a path. You've got two different pictures there. The top right one, that's a 10 gauge piece of wire where every single strand but one is broken. Will it show continuity? Yes. Is that wire good? No. And just below that is a wire that somebody stabbed with their test light. They got full of green corrosion and everything. Same difference. Doesn't matter if every strand is broken or if it's full of corrosion. You still can't pass any current, but is it going to show continuity? Yes. So there are things that are great about continuity tests, but you have to be careful. If you're only checking, say, does this wire go from point A to point B? Yes, it does. I at least know it's not broken, but it does not mean that circuit's any good. Hold function is, we used to have this at the first of the slide, but when we start talking about some of these new functions we're going to cover now, hold function is something that is very handy for you to remember. Some of them call data hold, some of them just refer to as hold, but what this gives you the ability to do is to freeze a test result. And some of you that know me and have known some of the tests we do at tech events is trying to hold two meter leads and write down an answer, or trying to go back to that service voltage or whatever. So with the data hold, whether you're going across a battery, you're going across a wire, going across a resistor or a sensor, it allows you to hit it, put those leads on, hit the hold button, it's going to freeze those results. So it makes it much easier for you to go back and to do a test on it or to verify what you're reading. So very, very handy to use, and don't ever forget to use it. The other ones, and the meter that we're showing today does not actually use it, but a lot of meters do have a min-max function. And that if you are looking at a voltage that is going up and down, you may be making connection, many different functions, but it allows you to hit that button and turn that function on. And say you're going across an alternator, you're going across a liftgate motor, but it will allow you to capture the highest voltage it saw and the lowest voltage it saw. You can go back through and look. It says, hey, while it was running, it dropped all the way down to 6 volts. There's something wrong there. The X-Tech does not have that function that we're talking about, but it actually has a function that's probably even cooler, called the relative function. Now, this can do several different things. It can act as a zero function. So your meter leads are out of whack and it's reading, 2 ohms with just touching the leads together. You can hit the relative function and it takes your meter back to 0, and then you can do a resistance check, and it is going to be more accurate. I almost a little scared to tell people that because they're going to think it's a fix for bad leads. If your leads are out of whack, like Austin was showing you before how to test them, you have to replace them. You can't just, well, I'll just subtract this from all my tests. The relative function can do some of that, but it is no replacement for making sure your meter is in optimal condition. The other thing that's very handy with is you can use this as, basically doing a voltage drop check. That if we had say just a simple circuit, or if you're doing like lighting on a trailer, you want to compare 2 different voltages. And on a truck, a lot of times your meter leads are long enough to do the voltage drop like we showed you before. On a trailer, it's much longer. You may not be able to do it, but you can take your meter and go across the source. Now, when we say source, that may be the batteries on the truck, that may be the nose box on the trailer, but where we're starting our test. And say, we're doing a brake lamp circuit on a trailer. You apply the brakes, you read the voltage across the 7-way inside from the brake lamp in the ground circuit. You hit relative and it's going to zero it out. Then you can go back, if you see here on the diagram, you go back to the brake lamp circuit at the rear of the trailer, and whatever it shows is going to tell you the difference it saw from the front to the rear. So if you were at 12.6 at the nose of the trailer, and you go back to the rear and it says 1.6, that tells you had a 1.6 volt loss from the front of the trailer to the rear of the trailer. And if you do the math, it says, hey, you're only getting 11 volts at the rear of the trailer. So relative is a very, very handy function once you get comfortable with using it. Now, still got to make sure you use all your functions right and are familiar with them before you try to use this, but relative can be very, very handy. Got a couple questions here that came in just to make sure anything we need to handle right now. One of it, last question came in is, why do you get continuity on a corroded wire if there's only one strand? Because it's still connected. That wire cannot handle any current, but it is still electrically connected. So it is going to show continuity. That's, if you were to even hook up a small lamp at the end of that circuit or something, it may create so much voltage drop it doesn't even work now, but it is going to show continuity because there is no load on it. Another one brought up a good point, should have mentioned, is on continuity test. The other thing you're not only looking for is that wire still connected. Yes, it is, but the other part is almost more important. Is it connected anywhere it's not supposed to be? And one thing, especially on older cars, or people that have rewired, they use cheap wire, that if you use GPT wire or general purpose wire, the insulation that's used on that will actually melt and reflow. So if you get a wire that gets hot, that insulation will actually run off, then it actually burns through other circuits. So that's very handy. It says, not only am I supposed to get power from point A to point B, but it should not ever go over and touch point C. So thank you for mentioning that. It is a good thing to remember. Is not only am I supposed to have continuity between here and here, but I'm also not supposed to have it between here and other places. Next function we're going to talk about is pulse width modulation. Some of you remember this from the training boards. But pulse width modulation is basically turning off and on a circuit to adjust the voltage or adjust the current. And this is used on lots and lots of different applications. You know, most people don't even realize on today's trucks, and been on cars for years. But daylight running lamps. With some applications, it's the same headlamps as nighttime driving, but they run through pulse width modulation. It says they're only turning on 70% of the time, so they basically operate at 70% output. So rather than having separate lights, it's a way to do it. Talking about blower motors a lot today is, used to be we had a blower motor resistor, and it would control, basically give you 3 blower motor speeds. With pulse width modulation, it basically becomes an infinite blower motor speed. You notice you don't have the low, medium, high. Now you just got kind of a rotating control that gives you basically infinite blower motor speed. Dash light dimming, someone else just mentioned too. Fuel injection. It's all a matter of whether you're at idle or full throttle. Is how long are those fuel injection or fuel injectors operating to provide enough fuel to do their job, but not waste fuel. So pulse width modulation has lots and lots of uses on today's trucks, and some stereo systems. You name it. Anything you're trying to control an output of more than just on/off, you're trying to give it a percentage. But if you look on your meter, not all meters have it for a hertz and frequency, but pulse width modulation on the X-Tech, you're going to use the second function up, which is hertz in percentage. And if this was a fuel injection unit or a fuel injected harness, you're just going to plug your 2 meter leads into it, and it's going to tell you what that value is. So if you look right now, it says 0.45, so that injector is on 0.45 out of 100%, or 45% of the time. If you were to rev that engine up and it saw that it needed more fuel, then that number is going to go up, versus also low speed or idle, it's going to be on less. Same thing, if this was a dash light like someone mentioned, if it said 80, it says your dash lights are at 80% brightness. Next one we're going to talk about is frequency. Why would I ever have frequency? Well, if you look at today's trucks, how many trucks have inverters in them? If you do have a driver complain that stuff doesn't quite work right, you may have a defective inverter. Just like anything we talk about today, is you get what you pay for. If you buy a cheap inverter, your efficiency is going to be off. It may not be anywhere near the right frequency. It may not have very good control over the frequency. If you're working on a generator, that generators, one of the biggest things that impacts a generator is what engine speed you run it at. And a lot of times there will be a recommendation to run it at full throttle or half throttle, whatever. Or when you use one, you're out campus, hey, that thing sure seems to work better, or a device seems to work better, under different scenarios. And that's again if it's, how it's trying to produce or how it's producing the right frequency or hertz. That anything in the U.S., home, AC should be 60 hertz. Most, places overseas are 50 hertz. But you need to check it and make sure it is the right frequency, and make sure whatever that device does have pretty good control over what it's producing. So in this example here, we just showed a wall outlet. It could be in your office, or it could be in a truck, or it could be in your hunting cabin. But again, we're looking for 60 hertz. One thing we talked about before too was this meter cheat sheet. It is available in the resource category or channel here. This is very handy for you to keep in your toolbox next to your meter, or even punch a hole through it and put it on your meter. Just say, what's that idiot say, and how do I do this formula, that formula? Makes it handy for you to have that. Now, we are about done. We're going to go through and answer some more questions, but no matter what, Please stay on for a couple different things we want to make sure we cover, and there is a survey afterwards we'd like for you to do. But one thing, we are continuing to offer this meter kit. If anyone does need one for their shop or for personal use, there is a promo code you can use to get the price. And also, we've had some people that have inquired about the training boards that they've seen us use before. This is something we designed not only as a test for technicians, but it's a good self-training device to use all these different functions. And I'm going to see if we do have any questions we missed. If anybody has any questions, please don't hesitate to key in now. One person had a question is, what percentage of max load do you recommend to test a circuit at? And it really kind of depends what device you're talking about. I would try to match it as much as you can. That if it's, again, a blower motor that you know pulls 15 amps, I would try to use something that's going to be very close to that load, what it's going to have to operate at. Again, we talk about RP129, because there is so many variables in that, they made the spec that says at 500 amps, you're allowed no more than half a volt. But again, try to simulate as much as you can for what that load is. When checking continuity, is there a right way to connect black and red? No, it really doesn't matter, because all it's doing is trying to make that complete circle to check the entire circuit. So there's not a reverse or proper connection to continuity check. And one thing about continuity check that didn't get a chance to bring up that just popped in my head was you have to be very careful using continuity check too. A lot of times we'll see people working on trailers make this mistake, is they think they've got a wiring problem or whatever. They'll go up to the front of the trailer and go from, say, yellow and green to check continuity, and it shows continuity or the meter beeps. What's wrong with the trailer? There may or may not be anything wrong with the trailer because it can go back through the filaments of the bulbs if it's got incandescent bulbs. So you have to be very careful when you do those checks that, it may have a path back to ground, you just don't realize. Same thing, anything that's got a coil. A relay, a solenoid, AC clutch are all coils. So one side is going to go to ground. So you have to be careful when you do those checks. You're not condemning something, that just had a path back that you didn't realize it. So if you are checking something that's got a relay, unplug the relay, disconnect one side of the solenoid. Just many things that you have to do to be careful to make sure you don't get a false positive and there's actually nothing wrong with it. Had someone ask about, different types of tools. Try not to mention anything specifically, but there are different types of, deluxe test lights or whatever. There's nothing wrong with those. You just have to be careful, and make sure you're trained properly on it. Some of them do apply a fixed load. Nothing wrong with it, but again, you got to make sure what that load is and is it a proper load. They do require some extra training because of how they operate, so you got to be careful. And that's, again, a totally different training thing, so I don't want to go into that any more on that. Yes, someone also mentioned continuity check. It's got to be done unpowered. Yes, good reminder, if you are using continuity check, or even ohms for a lot of things, is make sure you're not checking live circuits. Not only can it damage the meter, but you could hurt yourself or damage something, so be careful on that. So, excuse me, I'm just going through and checking some of these, make sure I'm not missing any questions. While I'm doing that, I do want to remind everybody on the Resource Center that there is the meter cheat sheet, information about us, myself, and also, too, there is a link for the test. I know a lot of people are kind of excited about that, and we're very excited to be offering it. But in the links down below, there is a link for the test so you can take it immediately. Worst case scenario, 24 hours from now, or basically noon tomorrow, you will get a link with the recorded version of this, and also you will get the link for the test. So feel free to do that. A couple things I do want to remind you on it is you will be given 40 minutes to take that test. It is 27 questions, and you have to get 22 answers correct to get a passing grade and get a certificate. But it will provide a personalized certificate, not only that you attended this, but also you passed the curriculum for it. And again, several other questions about some of the different load testing devices and stuff. We do not offer one. There's just so many different ones. We're just happy to get people up to speed and using a multimeter properly. One of the biggest things I tell people about a multimeter, if you're ever going to get good at using a multimeter, is you got to use it. People always want to go back. And I think that's it. So I am going to bow out, tell everybody thank you very much. And again, this was Multimeter 102. We did cover some new material, especially at the end with the frequency, pulse width modulation. And one of the biggest things is to be able to provide a test and get feedback from everybody. So I am going to bow out and turn this over, and there will be a quick survey for you all to take. Please stay on, give us any feedback, and also good luck with the test tomorrow, or if you are going to log on and take it now.